talk about how to find the areas of circles, sectors, and segments. So area of a circle, you have probably seen before. Area of a circle is equal to pi r squared. And that is the equation for an area of a circle. So know it, love it. Area of a sector. So a sector is, if I have a circle like this, and I carve out from the central angle, right? And I want to find this area here. This is called a sector, okay? So I'm going to call this point H, O, P, and the area here is going to be equal to the measure of arc HP divided by 360 degrees times pi r squared. And if you think about this, this should make sense, right? Here, what I'm doing essentially is I'm saying, well, area of a circle is pi r squared, but what fraction of that area do I have? And the fraction of the area that I have is going to be the same fraction as the fraction of this amount of arc over the full 360 degrees of arc in a circle. So, you know, if this were 45 degrees, I'd do 45 over 360, get some decimal, and then I multiply it by pi r squared, and that's the area of the sector. For this segment, segment's the kind of less obvious one. So if I take this, I take a chord, and I want to find this area. Not immediately obvious how I would do this, right? But if I draw my center, I draw a radius to there, and I draw a radius to there, then what I can do is I can find the area of this entire sector and subtract from it the area of just this triangle, okay? And this is an isosceles triangle because this is R and this is R, where R is the radius of the circle. So to find the circumference, find the area of a segment, we do the area of a sector, then you do minus the area of triangle. I guess we'll give it a name. I'll call this AOB. Triangle AOB. Okay, and that would give me the area of the sector here, right? So I take the full area of the sector, subtract from the area of the triangle. What I'm left with is the area of just that segment of a circle. So let's do some examples. If I have an area of a circle, circle O, I want to find the area, and it has a diameter of 10. And therefore its radius is 5, right? So here you can just plug in A equals pi r squared. You're going to have pi times 5 squared, so you're going to get 25 pi. That's, you know, the easiest kind where you're just going to be plugging into the equation. What if I want to find the circumference of a circle with area of 49 pi? This is a little tricky. I know that the equation for circumference is 2 pi r, and I don't have r. But I can use the area equation to get r and then take that and plug it into the circumference equation. So if I go over here, I know that A is equal to pi r squared, and my area is 25 pi, so I have 25 pi equals pi r squared. If I divide by pi and then take the square root, I get that r is equal to 5. This means I can plug into my circumference equation and get 2 pi times 5, which gives me a circumference of 10 pi. Okay, so to do a little bit more involved there. Example 3, let's find the area of the sector of a circle that has a radius of 12 and it makes a 45-degree arc. So to do this is actually the exact thing I was talking about earlier. I'm going to say that the area is equal to 45 degrees divided by 360 degrees times pi 12 squared. So once I put all this into a calculator, get a number, I'm going to find that this is equal to 18 pi. That is the area of that sector of the circle. Okay, so now let's do the weirdest one, where I want to find the area here of this segment. Okay, so to find the area of this segment, what I'm going to do is I'm going to say, well, this area has to be equal to the area of the sector, which is going to be 90 degrees divided by 360 degrees, times pi 10 squared, r squared, minus the area of this triangle, right? And the area of the triangle is 1/2 10 10. Right, nice isosceles triangle here. So this is going to give me 25 pi minus 50. And this is my area, my total final area. You could get like a decimal if you wanted, but I just prefer leaving everything in terms of pi. I think it's nicer. And that's it. So a couple things you can do here, a couple equations, but as long as you can, kind of figure out, okay, fundamentally we always need to get to one of these spots where we can evaluate it. Often, you'll draw some triangles or whatever if you have to draw triangles, but you do that in algeometry. So that's it for areas of circle segments and sectors. Thanks for watching.